1D, dividing radicals and rationalizing their denominators. So, first of all, we need to know that the denominator of any fraction can never ever equal 0. And the denominator of any fraction can never ever be a square root. It cannot be an irrational number. So, we can have a square root in the bottom as long as it's a perfect square. If it's not a perfect square, we have to rationalize our denominator. Rationalizing means we have to get rid of the root sign in the bottom. Okay? So it says there's 3 requirements that must be met in order to simplify quotients of radicals. So quotients means we're dividing. That's all it means. So it's going to be in fraction form and we're dividing. 3 ways to do it only. So there's 3 conditions we must meet. There must not be a fraction under your root sign. So that means we have to separate the top and bottom into radicals. Okay? So you have to separate your top and bottom into the radicals. They cannot be a fraction under the root sign. The denominator cannot have a radical in it. Okay? It cannot. And the denominator cannot have a negative. Where do our negatives usually go? They float to the top always. So this guy's negative should have floated to the top. Okay? So that just means we can't put negatives on the bottom of anything. Okay? So no negatives on the bottom, no radicals on the bottom that aren't perfect squares, and we can't have fractions under a radical sign. Okay? Those 3 conditions. So because of that, we do what's called rationalizing our denominator. Okay? And the way we do that is we multiply. Okay? It's a multiplying thing, actually. Okay, let's take a look at a couple examples. All right. If we take a look at this first example, it says the quotient property of square roots can help us with trying to figure this out. Okay? So what have we done here? These are equivalent because what have we done? We have separated the fraction into roots on top and bottom. Okay, into roots on top and the bottom. So the first thing is we got to separate them. So if we take a look at the next example here, the root 36 over 4, that's the same as saying root 36 divided by root 4. Well, that means I'm going to take the root of each of them. I need to solve each part separately. Because 4 is a perfect square, it can stay on the bottom. Because the root sign disappears when I solve it. The root sign is going to disappear when I solve the 36 too, because it's a perfect root. So as the answer comes out, I get 6 over 2. Now you're not going to leave it as 6 over 2. You need to simplify. So this would be your final answer. Okay? That's what it's talking about. Now, can we just divide the numbers underneath and get root 30 and just get root 9? Absolutely we can. Only if they divide evenly. If they divide and give us a decimal, we can't do it that way. We must separate top to bottom. Okay? So if they divide evenly, yes, you can divide them. All right. So, what are the rules then? Let's write the rules down. So our rules are rules for dividing. Okay, here's our rules for dividing. Well, first thing, indexes must match. Must match. That was hard to say. Okay, indexes must match. Same as when we add and subtract and multiply. The indexes have to match or you can't do it. All right. Then, the next thing we do is we divide coefficient by the coefficient. Now, if you forget what that word means, coefficient means it's the number in front of the radical sign. We divide the numbers in front by the numbers, in front. Then, we divide the numbers under the radical signs by the numbers under the radical signs, if they divide evenly. So, we divide, they're called radicands. Then we divide radicands by radicands. Okay, so you divide your radicands by radicands. So we're going to give this a try on the bottom of the page there. Make sure you get those steps written down. Let's try these ones together. So, I take a look, I've got a hidden 1 in front of my radicand, so I don't have to worry about them. I just take the inside divided by the inside. So it's 30 divided by 6, what do I get? 5. It stays under the root sign. So I get root 5 for an answer.
If your answer is like, say it was like root 4, would you break that down?
Root 4 is an exact root, so you come out of the root sign automatically. And then you just break the top down. Okay, if the root 4 was in the bottom. We're going to do a couple examples like that. Just waiting.
So like
yeah, we're going to do some examples like that, so just wait. Okay, you're jumping ahead of me here. All right, yes? Yep. The next one has numbers in front. So we need to divide the numbers in front by the numbers in front, and the numbers underneath by the numbers underneath. So 21 divided by -7 is going to give us a -3. 50 divided by 2 is 25. That's still under the root sign. Now what do we know about the number 25? It's a perfect square. So that means he comes out of the root sign. So the -3 comes down, the root 25 is 5, and now I solve that. So I take -3 times it by the 5, and I get an answer of -15. So sometimes you get answers that have no radicals in them at all in the end, and that's okay. Okay? Okay, on letter C, you're going to notice these numbers in front, 6 dividing by 18. Like I said, you get a decimal. So math bracket. Okay? You need a math bracket. It's going to stay as a fraction. Okay? So they both divide by 6. The top number becomes a 1. The bottom number becomes a 3. So in front of your radical, you get 1 over 3. Okay? So what I've actually got now is 1 root 24 over 3 root 3. That's what I've got now after I've reduced the front of it. Now we're going to divide underneath. What's 24 dividing by 3? 8. Good. It's still under root sign, so I have to keep a root sign. So I'm going to get 1 root 8, and it's now over 3. I still have a 3 on the bottom here. This little 3 here does not go away. He's still on the bottom, and he's not under the root sign. Okay? So it's root 8 dividing by 3. Now, root 8, is it broken down into a lowest term root? No. We have to break them down if we can. So we're going to break down root 8. So I've got root 8 over 3, but root 8 gives me root 4 times root 2. So that's going to give me 2 root 2. So this gives me 2 root 2 dividing by 3. Now, let's say the number in front, who's a 2, let's say that number 2 divided evenly by my 3 on the bottom, then the 3 might disappear. But right now, the 2 in front of the root 2 does not divide evenly by a 3. So this would be my final answer. And yes, it's an okay final answer because you do not have a root sign in the bottom. That's what we're trying to get rid of, is the root sign in the bottom. Okay, letter D here. We're going to notice we have root 27 and root 16. What do you know about the bottom of this? It's a perfect square. So we're going to break down root 27 to give us root 9 times root 3. And the root of 16 we know is 4. We further break the top down because I can take the square root of 9. So this root 9 is going to become a 3. And it's going to be in front of the root 3 that's still on top. And the bottom stays a 4. And we're done. Yeah, we can't go any further. As far as you can go on that one. All right. Now when we get letter E, we've got more than one thing on top. So when you've got more than one thing on top, they all have to divide by what's on the bottom. So just write what's on the bottom underneath all of them. So I've got this one dividing by 2 root 3 and this one dividing by 2 root 3. Okay? They each divide by 2 root 3. So now we do what we did before. we divide the numbers in front. 6 divided by 2, what do I get? 3. Good. 18 divided by 3, what do I get? 6. So then root 6 comes beside the 3. That's what this first part simplifies to. Does everybody see where that comes from? Let's take the second one. The second one has a 10 and a 2. What's 10 divided by 2? 5. Good. It's positive, so it's a plus 5. And then I'm going to take root 24 and divide by root 3. What do I get with that? Root 8. Good. We're going to break him down later. We're just still dividing. Now we're going to take the next section. I've got 8 divided by 2. What's 8 divided by 2? 4. Good. And is it a positive 4 or a negative 4? Positive 4. Good. Now, 12 dividing by 3 gives me what? Root 4. Good. Now we're going to break down everything else we can. Look at my green one, 3 root 6. Does it break down? No. So he's just going to come down by himself looking the exact same. So 3 root 6 does not change. But if you look at the blue one, root 8, he does change. He breaks down. So the 5 will come down, and then it times by root 4 times root 2. Okay, and then I'm going to break him down and simplify him. So that's going to be 5 times 2 root 2, which gives me, when I multiply the 5 and 2 in front, what do I get? 10. Good. So I'm going to get 10 root 2. That's what that blue one gives me. Okay, now I'm going to work on the red. So I'll move that over so I can work on the red one. Fancy, hey? Okay, 4 is going to come down. What do we know about the root 4? It's a perfect root. So I solve it, I get 2. It's got to multiply by that 4 in front. So he becomes what? 8. Positive 8. So now my final answer is going to look like this. I'm going to have 3 root 6 plus 10 root 2 plus 8. Then I take a look and see if there's any of those that have the same radicand so that I can add the numbers in front. Are any of them the same? No. So I cannot go any further. That would be my very final answer. Does it matter who writes first and who you put first? No, it can be in any order. Okay? Let's try the next one. These 3 are your practice. Try these. Push pause now and play when you're ready. So if you take a look at the first ones, most of you got this right. You took a look and you divided 6 and 3 and got a 2. Root 48 dividing by root 6 gives us root 8. But root 8 breaks down into root 4 times root 2. The 2 in front stays and comes in front as well. So this guy comes down, they all come down. I have a 2 times 2 root 2 to give me 4 root 2. Okay, check your work. Well, let's take a look at B. When we're going to look at our numbers in front, we go 6 divided by 12 math frac. That's going to give us 1 root 30 over 2 root 8. Because 6 over 12 reduces to 1/2. Now I notice that root 8 will not divide into root 30. But I can break root 8 down. I can't break root 30 down. But this guy breaks down. 2 comes down times root 4 times root 2. This guy comes down. I get 2 times 2 root 2 to give me 4 root 2. That's the bottom. So what I've actually got is root 30 now on top of 4 root 2. Now, 30 will divide by 2. They're both under root sign, so I can divide them. So 30 divided by root 2 gives me root 15. That goes to the top. So this will give you root 15, and the 4 stays in the bottom where he started. Okay? Because the 4 is still in the bottom. So he's got to stay where he is. Okay? Now over here, I'm dividing both of them by 2 root 3. Okay? You almost done? I can erase this part now? Okay? Looking at our last one here. They're all dividing by 2 root 3. So 4 divided by 2 and gives me a 2. 12 divided by 3 and gives me root 4. Then I look at the 10. 10 dividing by 2 gives me a negative 5. 6 dividing by 3 gives me 2. So I get a root 2 cuddled up to that 5. Now what do you know about the 4? It's a perfect square root. So the 2 comes down. The root of 4 comes down, which is 2. and it connects to this guy who does not break down. So I just connect minus 5 root 2 at the end. Now, you're going to multiply these numbers and get 4, and then you put your minus 5 root 2 at the end. The 4 and the 5 cannot subtract or connect because the 4 does not have a root 2 with them. So I can't add those together. So this is my final answer. I can't go any lower. That is the end of section 1 of dividing radicals.